Hello, Mr. Serrano here. These are SAT 2023 sample questions. Let me try to explain. Number one says if 3 is one of the solutions of the equation, what is the value of A? So if 3 is one of the solutions, we know what that means. It means that X can be equal to 3. Let me see if I can activate my pen so I can write here. Okay, here we go. Okay, so X can be 3. Let me make it a little darker. And better color. See? So X could be 3. So we substitute that for X. So instead of being X squared, it's going to be 3 squared plus 6 times A times 3 plus 27 is equal to 0. Okay, so we now need to solve for A. So 3 squared is 9. 6 times 3 here is 18, plus 18A plus 27 is equal to 0. Okay, let's move the 9 and the 27 to the other side by subtracting. So we're going to get 18A is equal to negative 27 minus 9. 18A then is going to be equal to negative 36. Dividing by 18, and X is equal to negative 2, B negative 2. Let me clear the drawings. Let's see if I can go to the next screen. Maybe I shouldn't have this on. Okay. Since I'm not using the PowerPoint drawing, I'm using Zoom annotations. Okay, so find the value of X. So, okay, so we need to have denominators that are the same. The common factor, least common factor of 2, 4, and 6 is going to be 2, 4, 6, 8, and 12. 4 is going to be 4, 8, 12, and 6 and 12. So that is going to be 12. So I need all denominators to be equal to 12. That means I need to multiply this fraction times 2, both top and bottom. This one times 3. And the other one 4 times 3, so the other one times 6. So that 2 times 6 will be 12. So now let me write that. Remember, we're going to distribute the 2. So that's going to give me, let me see, 4x when I do this, right, multiplying. So it's going to be 4x plus 8 minus 3x equals 18. And of course, 2 times 6, 12, all of it over 12. over 12 over 12 over 12. All right, we can multiply everything by 12 to cancel the, kind of like this, to cancel the denominator. In this sense, like this, everything gets multiplied. The left and the right side of the equation gets multiplied by 12, so we just cancel the denominators. And so we are left with 4x plus 8 minus 3x is equal to 18. Okay, 4x minus 3x is just x, 1x or x. And when we subtract 8 from both sides, the 18 minus 10 is going to be equal to 10. So x is equal to 10. That's my option right there. Okay, let me clear my drawings. You go here and go here and go to the next slide. Trying to move right along because SAT is about time, so whenever we can find a shortcut, we will. Let me close that. Okay, so this is a thing about exponents. Question about exponents. Okay, let me find my Zoom annotations. So here we are. Okay, so a to the 2m 8 over 10. Whenever we have exponents with the same base a, we're going to keep the base and subtract the exponent. So that means that in this case, I'm talking about the beginning there, this is going to be a to the 2m, keeping that base, minus 10 because the 10 is in the denominator. So 2m minus 10 is equal to a to the 12. So that means that 2m, so that's going to be equal to a to the 12. Okay, once again, we're going to drop the bases because the exponents have to be the same. If the bases are the same, it's the same quantity. So I'm going to have that 2m minus 10 is equal to 12. Let me add 10 to both sides, and I'm going to get the 2m plus 10 plus 10 is equal to 22. Dividing by 2, and m is equal to 11. Now we need to find m, which is 11, and multiply it times n. So let's find n. A to the 3n is equal to the a to the 21st. Because a is the same, if the bases are the same and is equal, then the exponent obviously has to be the same, so we can drop the bases and we get 3n is equal to 21. What number times 3 gives me 21? That number is 7, and is equal to 7 because 3 times 7 is 21. So we need to find m times n. 11 times 7. 11 times 7 is 77. Do I have a choice? Yep, I do. Okay, so since this is being recorded, I can erase and you can go back and see it. Clear all drawings. Let me close this so I can go and move to the next slide, hopefully. Okay, school has hired 30 teachers, and this is 40% off the number of teachers next year. How many teachers next year? So basically the question says 30 is 40% of what number? All right. All right, let me see. 30 is 40% as a decimal, as a fraction, sorry. 30 is proportion. 40% of what number? So we're looking for x, which is the of what number? We don't know the what number, so that's my x. And we're going to cross multiply like this. X times 40 is 40x. Is equal to 100 times 30, which is 3,000. 3 times 1 is 3, and then 1 0 from the 30 and 2 zeros from the 100. Okay, so we're going to then divide. X is going to be equal to 300 divided by 40. We can drop a 0, and it's 300 divided by 4. The answer is not here, but I gather that 70 is 75. The answer may be C or D. C or D. I don't know which one because I got the picture cut off. 75 is gonna be, so 30 is 40% of 75. That is the right answer. I would check it for you, but I have, so 75 times 2 is 150, so times 4 is 300. So it does work. I need to move on, so I don't want to make an hour video, and I don't want to make anything that will take extra time. What is the value of X? Okay, so we can clear some of the things in the top. So let's distribute first. Times, so 3X plus 15 minus 8 is equal to 17. 17, I said. Okay, that's not gonna work. So I'm gonna try to do it again. Is equal to 17. A little better. Let's erase that. Let me use these other annotation tools. So distribute the negative number. So negative times a negative 1, remember? Negative 1, invisible 1. Negative 1 times a positive 6 is a negative 6. A negative 1 times a negative x is a positive x. All of this was over 7, all of this was over 5. So what can we combine? 15 minus 8. So we get 3x plus 7 is equal to 17 minus 6, which is 11, plus x over 5. This is over 5, the other one is over 7. So again, like in the proportion below, we're going to cross multiply. So now we're going to do this and that, which means I need to multiply 5, I should say. 5, because it's coming from that way. 5 times 3x over 7, and then 11 plus x times 7. So that's going to be, if I distribute again, that's going to be 15x plus 35. It's going to be equal to 7 times 11 is 77 plus 7x. Let me take away the 7x from here. And let me take away the 35 from here, because I don't have a whole lot of room. And so 15x minus 7x is 8x. Back to the blue. 8x equals 77 minus 35, which is 42. Dividing by 8, I'm going to get that x is equal to 42 over 8. They're both even, so if we divide both top and bottom by 2, I'm going to get that half of 42. 42 divided by 2 is 21. 8 divided by 2 is 4, and then 4 and 21 do not have a common factor. So I hope there's an answer, 22 over 4. That's A. It's 22 over 4. Okay. So again, for the sake of shortcutting, I'm trying to be brief and move on as quickly as I could. All right, again. Okay, so what happens here is that we have two different bases. One base is 3, as you can see, and the other base is 27. So the question is, can we convert the 27 as a power of 3? That's it. Let me repeat. Can we write the 27 as a power of 3? Hopefully, uh, 3 to the power of something is 27. That's what I'm hoping for, right? So let me see. 3 to the power of 0, like anything to the 0 is 1. 3 to the power of 1 is just 1 factor 3. 3 to the power of 2 is 3 times 3, which is 9. And 3 to the power of 3 is 3 times 3 times 3. 9 times 3, which is 27. So instead of writing 27, I'm going to write 3 to the third power. And then this other x minus 6 is another exponent, so it needs to be multiplied. So x minus 6 and distributed. So getting back to where I was here with the beginning, this is already base 3. So I'm going to write, I'm going to write 3 to the 2x minus 16. That's this, not green but blue. Is going to be equal to the new thing that we found in green. The new way to write that quantity is 3. So now we have the same basis. 3 times x and 3 times negative 6 is to the 3x minus 18. 3x, not 2. Okay, some trouble with the board here. But that's a 3. Okay, fair enough. So we can draw the bases because one quantity is equal to the left is equal to the right, and the base is equal to the base. That means that the exponents have to be equal to each other. So the quantities are the same. Otherwise, we wouldn't have an equal sign in the middle. So 2x minus 16 is equal to 3x minus 18. All right, for the sake of being quick, let me add 18 to both sides. And I'm gonna get a 2 on this side. Now this 2x, I'm going to subtract them. And I'm going to subtract them from here. And so I'm gonna get x. So right there, 2 is equal to x, or x is equal to 2. Choice D. Okay, did I skip one? Okay. X is greater than 0, and indeed my answers indicate that x can be 0, 1, 2, and 4. So we already know that A cannot be the answer right there. Let's start taking use of those test taking skills. So cannot be, it has to be 1, 2, or 4. So I have basically, I need to solve for x when x minus 3 is equal to the square root of x minus 3. Okay, so could it be 1? 1 minus 3 is negative 2. I'm going to substitute 1 for x. So that would be negative 2 here, and here we would have the square root of negative 2, which we cannot have. We cannot take the square root of a negative number, so it cannot be 1. And again, if I do 2 minus 3, if I substitute 2 for that x, 2 minus 3, that's going to be negative 1. It's equal to the square root of 2 minus 3. Again, it's going to be the square root of negative 1, which I cannot have. This is a big no-no until we use imaginary numbers, which we are not using yet, nor are we using in this course. So it's all right. So we know that x has to be greater than 0 anyway. That's all we need to know. All right, because the SAT does have imaginary number questions, but no number here is greater than 0 with -2 or with -1. So the only possible answer, that's when we use 2 for x, so the answer has to be 4. And that was just substituting into the equation and eliminating my answers without actually solving for x. That would be maybe for the long video, but not now. I'm trying to teach you some shortcuts too. Okay, if the center of the circle is at 3, 6 and the radius is 4, what is the equation? Okay, so to do that, we need to know how to write the equation of a circle. The equation of a circle is the 3, 6, instead of being x and y, we're gonna call that h. So, sorry, we're gonna call 3, 6, we're gonna call that h and k. So the equation is x minus h to the power of 2 plus y minus k, again to the power of 2, is equal to the radius squared. So my radius is 4. 4 squared is 16. So we can eliminate those answers. So it has to be C, C, but there was a D, so let's make sure. So h is 3, so it would be x minus 3 plus y minus 6. Quantity squared is equal to 4 squared or 16. So indeed, that's what C says. This is exactly what C says. X minus 3, y minus 6, both quantity squared, both added, and yeah, so that's the formula for the circle is x minus h to the second power plus y minus k to the second power, where h and k, positive h and positive k are the center, whether positive meaning it's not the negative version. H could actually be a negative number. It's equal to the radius squared. So 4 is the radius, so we're gonna use 16. Here is 4 in case you forget to square it. Here is 8 in case you make the mistake that 4 to the second power is 4 times 2, which is not, it's 4 times 4. So it's 16. Okay, in the following figure O, which is a circle, is the center, find the area of the shaded part. So the shaded part is only the area that you see shaded, which is between the circumference, a quarter actually of the circumference and the triangle. Okay, so what we need to do fairly is divide the area into 4 quadrants, because we can see that we have a right triangle, and the triangle has the 2 legs are the radius, so it's an 8 by 8, because you can see always the center. It tells you that it's the center. And so this is another 8. Now what would be the area of the whole? The area of the whole circle is pi times the radius to the second power. The radius is 8, right? Because it goes from the center O to the end of the circle to the circumference. So I'm going to do pi times 8 to the second power. 8 to the second power is 64. Now this would be the whole area of the whole circle. But I need to get rid of 3/4, right? And only worry only about this quarter, if you will. So the other 3/4 I need to divide it into 4 parts because the triangle is in one of the 4 parts. So 64 divided by 4. That's gonna be 16 pi. Sorry, 16 pi minus the area of the triangle. So I can totally see that this is incomplete, doesn't have the subtraction of the area of the triangle. This has it backwards. So it has to be B. And I would normally say let's move on because this is about wasting time. Once you know that there's no other possible answer, move on and come back to it when you have time for the SAT, but you wanna cut time. But since this will take, I'm not being time right now, I'm just gonna say that the area of a triangle is 1/2 of the base 8 times the height, which is also 8, right? So that would be, we already did 8 times 8, 1/2 of 8 times 8, which is 64. 1/2 of 64 is 64 divided by 2, which is 32. Half of 64 is 32. And indeed, that's what we have there, but we didn't need to go into all that. You'll save a minute by just realizing that it's 16 pi minus some quantity minus the area of the triangle, right? 16 pi is a quadrant of the area of the circle. And so minus the triangle because the triangle is not shaded. So has to be that. Maybe I should erase. Let me see. Where's my annotate? Annotate, erase. And then close this one and go back here and look at the next slide. Okay. All right, so this I'm gonna do again the short way. There's a long way, but I'm not gonna do the long way. Okay, so I have a trinomial here ending in -10, and I already have it factored as the product of x minus 1 and something something. I know that this has to be x because x times x, when we do, first, x times x is gonna be x squared, right? But the last two terms have to multiply to -10. I already have a -1, so -1, that's a -1, right? Times what number is gonna give me -10, because -10 is what we have here at the end of the trinomial. So that's the product of this number, let me see, of this number and that number here. So -1 times what is -10? Well, only 10 can fit here. So that's gonna be a positive 10. So that way, when we multiply -1 times positive 10, we get -10 over there. Very good then. So great. So we have to find B plus C. C is 10. What is B? Well, what is the coefficient of x here so that when I multiply x times x, I get 1x squared or x squared. So that means that the coefficient can only be 1. Any other coefficient, if it was 2 over here, would give me 2x to the second power, and that is not what we have. So B has to be 1. Remember that invisible number? Now we need it visible because it's 1x plus 10. When we add 1 plus 10, we get 11. See how easy that was? It's not so bad. And we didn't even have to FOIL or distribute the whole thing. Just using what we know about the last term of the trinomial is the product of this times C. Okay, so what we have to look in this question is the equation 20x over 2 over 2x minus 1 is in the form k, that just means a quantity, plus 5 over 2x minus 1. Notice the denominators being the same, 2x minus 1. So if we have 5 over 2x minus 1, that's a remainder, all right? That's a remainder. That means that we're looking to divide 20x over 2, 20x squared, sorry, over 2x minus 1. So as we know, this is going to be, a fraction is in over out. In over out. So I need to write 2x minus 1 on the outside, and in goes, as a division, in goes the 20x squared. Okay, so what I have to do is divide 20x squared, which is 20x times x, divided by 2x, by the first term of the denominator. So divided by 2x, okay. X divided by x is 1. 20 divided by 2 is 10. So 10x is what I need to write here. And rather than continuing and completing the long division, which is gonna take you 5 minutes of your not so generous time for the test, I can see at the answers. I can look at the answers and see that only B begins with 10x. Therefore, that's your answer right there. And unless you want me to explain in person or in another video by giving me a comment, I can show you how the 5 came about, but we don't need to, because there's only one that begins with 10x, only one choice answer, which is B. So we'll leave it like that. And moving on to the next question. This one said number 7, but I don't know exactly how many more we have. We don't have many more. I added 13 sample questions to this video. I don't know if they will, how many we have done, because they were not numbered until I saw this one. So, but it doesn't mean that we have, it's out of order. So all I'm saying is we may only have one more question there, maybe 2. Okay, if the polynomial below C is the constant, okay, so C is a number. So 2 times a number times x. If the polynomial is divisible by x minus 4, okay. So again, remember, we are doing the factoring, and we have x minus 4. If we have okay, looking for those annotations takes a while. Okay, so if x minus 4 was factored, that means that x minus 4 is equal to 0. So if x minus 4 is equal to 0, by adding 4 to both sides, x is equal to 4. Okay, so now I can substitute 4 whenever I see an x. I'm going to write a 4. So I'm going to go ahead and do it here in green. So I'm going to say 4 squared minus 2 times 4, which is the x, times c. Notice what I did there? I had a minus 2 times c times x. So I have a minus 2 times x times c is the same thing, plus a equals 0. So 16 is 4 squared minus 8c plus 8 is equal to 0. I can move the non-c's to the right by subtracting. So this is going to be, trust me on this one, negative ac. Trust me that when I subtract 16, it's going to look as a negative 16 on the right side. And when I subtract 8 on the left side, it's going to be a negative 8 on the right side. And the left side will be left with only the c's, the negative 8 c's. 16 and 8 is 24. So negative 8c is equal to negative 24. And 8 negatives go into 24 negatives exactly 3 times. So the answer is 3. We could have also done it by factoring, but again, if I explain this, it's just going to be the longer. If you want me to explain it in class, or if you're watching this video and you want to send me a message, I may be able to do it by factoring the way we did the other one. So I wanted to give you a sample of different ways we can expand all the way, or we can factor. Anyway, hopefully we'll be moving on. And it looks like that's the end of the video, is it? Let me see. Okay, thank you.